Hello and welcome to another Show Me with Mr. Oliver. Today we're doing multiplication word problems, and I might even throw in some division word problems just to really make you think about how it relates to multiplication. Okay, here we go. Firstly, we need to understand what multiplication is. 2 times 3 could mean 2 lots of 3, or it could mean 2 3 times. I tend to teach multiplication as 2 3 times. Let me show you what that would look like. 1, 2, and I'm doing that 3 times. So that's 2 times 3. That's 2 3 times. And that's the same value, different appearance. So some people see this as 3 lots of 2. I personally see that as 3 2 times. But as you'll notice that because of the commutative law for multiplication, it doesn't actually matter which way around you read it, as 2 3 times or 3 lots of 2. It's the same value, different appearance. But for the purpose of this, the first number I will call muchness. How much have I got? And the second number I'm going to call manyness. How many times did I have that amount? Okay, and in multiplication, unlike addition and subtraction, this is the first time you come across the cardinal and ordinal properties of number, which for primary school we're going to just call muchness and manyness. Okay, let's apply this to a problem. So Joe makes 5 trays of cakes. There are 5 cakes on each tray. How many cakes did he make altogether? You've noticed I've given you a grid there. If you want to pause the video and try it yourself before I show you, that would be great. So now's the time to pause, have a try before you follow on, and try that for each question. Right, here we go. So Joe makes 5 trays of cakes. There are 5 cakes on each tray. Well, there's 1, 2, 3, 4, 5 cakes, and we're going to make that 5 times. So that's 2 lots of 5, 3 lots of 5, 4 lots of 5, 5 lots of 5. Okay, you may want to do this with counters or pennies just to make it more concrete before you move on to a pictorial model. And as you can see there, the multiplication sum that I'm thinking of for this problem is 5 times 5. So I can just go counting in 5, 5, 10, 15, 20, 25. So here, how many cakes did he make altogether? 25. Okay, next problem. There are 5 children in a team. How many teams could you make with 40 children? Well, if there are 5 children in a team, how many teams could I make with 40 children? It's a multiplication problem, but it has a division element too. So I've got 40 children, and I'm wondering about groups of 5. How many groups of 5 is that? Well, if you write a multiplication sum as 40 equals 5 times, you'll notice for the division answer it's the same as for the multiplication sum I've just drawn. So let's have a look and see. So let's put them in teams of 5. That's 1, 2, 3, 4, 5. That's 1 team of 5. 2 teams of 5. 3 teams of 5, so I need to be counting in 5s when I'm doing that. So that's 5, 10, 15, 20, 25, 30, 35, 40. Now, really important now that I see I'm not just counting in 5s, as in going 5, 10, 15, 20, 25, 30, 35, 40, but for division I'm actually counting how many teams. That's 1, 2, 3, 4, 5, 6, 7, 8 lots of 5. So the answer to my question would be 8 teams. Okay, next question. 12 children are at a party. they eat 2 cakes each. How many cakes are eaten all together? So you can see I've set it up here. They have 2 cakes each. So that's one child having 2 cakes. That's another child having 2 cakes. So I'm thinking about groups of 2. Now, if I'm thinking 2 cakes each, how many altogether? Pardon me. There are 12 children. 2 times 12. Now, your child may not be able to do that, or you might not be able to do that if you're watching yourself. But what you should be able to do is go, well, I know what 2 times 5 is. That's 10. And I know what 2 times 10 is. Once I get there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 2. So I know that 2 times 12 is the same as doing 2 10 times and 2 more times. Well, 2 times 10 we know is 20. And I've got 2 more lots of 2 to do. That's 1 more lot of 2 and another lot of 2. So we've broken this problem into 2 parts to make it easier to work out using our 10 times table and our 2 times table. That's 20 cakes and 4 more. So they ate altogether 24 cakes. Next question. One spider has 8 legs. How many legs will 2 spiders have? I've set this up to show you that actually if you were doing this, you think, well, it's the 8 times table. That's 1, 2, 3, 4, 5, 6, 7, 8. That's one spider. 1, 2, 3, 4, 5, 6, 7, 8. That's 2 spiders. So what your child is actually doing is 8 add 8. But you can actually use your 2 times table for this too, because 8 and 8 is the same as 8 2 times, which is the same value as 2 8 times. So if you can do 2 times 8, so that's 2, 4, 6, 8, 10, 12, 14, 16. And 8 and 8, as you can see, is 16. So again, that's really useful, that commutative law, for using your 2 times table to help you with times tables that you haven't learnt yet, like the 8 times table. Okay, 7 days in 1 week. How many days in 5 weeks? Oh gosh, so this is really a 7 times table problem, so we're counting in sevens. 7 and 7 you might be able to work out is 14. That's 1, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Hopefully your child is learning the days of the week in order if they're in year 2. One of the objectives for year 1 and year 2 is to be able to spell the days of the week, so it's something worth practicing. So 7 days is 1 week, 14 days is 2 weeks. But if you're doing 7 times 5, and you're thinking, I don't know my 7 times table, well, it's the same value as doing 5 7 times, because in 5 weeks, you'll have 5 lots of Monday, like that, and then you'll have 5 lots of Tuesdays, and you'll have 5 lots of Wednesdays, then you'll have 5 lots of Thursdays, 5 lots of Friday, 5 lots of Saturday, and 5 lots of Sunday in 5 weeks. So straight away you can see that actually it's counting in 5s. That's 5 days there, 10, 15, 20, 25, 30, 35. If we were counting in 7s, I'd go 14, 15, 16, 17, 18, 19, 20, 21. 21 and 7 more, I should be able to work that out as 28. So, and then 28, 29, 30, 31, 32, 33, 34, 35. You'll notice that there are 35 days in 1 week. This is a really challenging problem for children to actually recognise that even though they know their 5 times table, that will help them with at least one sum in every other timetable. When you're doing 5 piles of something, if you look at it the other way around, so if you're doing 5 piles of 7, you already know that you can use piles of 5 7 times to work out the answer to that problem.